Okay. See, in the last class we have studied some of the basic concept of structural analysis. Today we are going to cover a very important concept, that is um indeterminate structure. Indeterminate structures. Now, in the last class we had mentioned that there can be two kind of indeterminacy. That is, one is the external indeterminacy, and the second one is the internal indeterminacy. Okay, now let us study first about the external indeterminacy. Let us study about the external indeterminacy. Just you have to keep in mind that external indeterminacy is caused by too many support. Just make a note of it. It is caused by excess number of supports. That is, if the number of support is more than those required to keep the structure safe and stable, it can be called as external indeterminacy. Here it is caused by excess number of support. Let us take for an example, that is, suppose this is a beam which is having a UDL. Let us take that the magnitude of UDL is 1.2 kilonewton per meter. Clear? Now suppose there are support A and C. Now see, to keep this beam in equilibrium, suppose support A and C is sufficient. You don't need any more support. But to reduce the reactive forces at A and C, that is RA and RC, somehow you introduce a support, that is support B. So see, here the B is a extra support. You don't need B because the magnitude of force is very less. It is only 1.2 kilonewton per meter. But you are introducing support B, that is to reduce the reactive forces RA and RC. Then this structure is externally indeterminate structure. It is also known as redundant structure. Redundant structure, because this extra support is also called as the redundant support. So it is also known as external redundancy. External redundancy, because of the redundant support at B. This is called as the redundant support or extra support. You don't need the support. Somehow you are providing the support to reduce the reactive forces at A and C. So this is the concept of external redundancy, which is caused by one or more support. Clear? Now what we can see, let us see a case study. Let us see a case study. Now what is a case study? I will just show you. Suppose this was your beam which was having a certain UDL. This was the beam and the magnitude, and we had provided a support at point B. Suppose this is A, this is C, this is B. Okay, now the magnitude was very less, as I had mentioned that you don't need a support at B for the safety and stability of the structure. The magnitude was 1.2 kilonewton per meter, and suppose it is 4 meter, it is 6 meter. So can any one of you tell me what is the total reactive forces which is coming on RA, RC and RB also we had provided? What is the total magnitude of force? We know it is UDL, so total force is equal to 1.2 multiplied by the distance is 6 plus 4, 1.2 into 10, 12 kilonewton per meter. Okay, now I had told you that you don't need the extra support at B for the safety and stability of the structure. So if you don't need B and it is a symmetrical structure, so RA and RB will be, RA and RC will be equal. If the total force coming is 12, RA and RC will be equal to 6. Sorry, it is 12 kilonewton, not meter. Total force is 12 kilonewton. So RA and RC can be equal to 6 kilonewton and 6 kilonewton. Suppose B is not there. Total force is 12 kilonewton. So RA and RC can be equal to 6 kilonewton and 6 kilonewton. I hope it is clear. Okay. Now let us mention this thing so that you will remember. Total force is equal to 1.2 into 10, that is 12 kilonewton. Now using different computer software, we can permute by the help of this permutation and combination, we can find out different set of value for A, B and C. Okay, suppose support B is not there. Okay, if support B is not there, then the beam may deflect like this. Suppose if the beam is deflecting by an amount delta. Okay, so see, if we are providing a redundant support, the function is to reduce this deflection to 0. Okay, now again one more case we can see. See, in this diagram we had not provided any redundant support at B. Okay, now suppose this was 6 kilonewton and 6 kilonewton, right? Now in the second case, with the help of certain computer software, we can see that if we provide a magnitude support, that is RB, suppose we are providing RB equal to 1 kilonewton. So total was 12, so 1 kilonewton we are providing at RB, so rest is 11, right? So 11, it is just an example. Suppose RA is equal to 5.4 kilonewton, RB is equal to 5.6 kilonewton. This is just example, and all these values are based on permutation and combination in different computer analysis softwares. It's just example, we are not solving any problem here. Suppose we are providing RB equal to 1 kilonewton, so that for in this case the deflection was a bit large. Suppose deflection is minimizing delta, so we can see that we can say that RB is doing its duty, so that RA and RB will be a bit less and RB will help to reduce the deflection to 0. See, still it is not 0. Okay, still it is not 0. So again, with the help of some computer software, again we can have some different set of value. Suppose again if we increase the value of RB, suppose the deflection is again minimum, it is still not 0, some deflection is there. Suppose we increase RB equal to 3 kilonewton. So if we increase RB equal to 3 kilonewton, how much force is left? Total was 12. 3 is going to RB, so it is 9, right? So 9, we can just suppose, it is not definite, with the help of software, suppose it is equal to 4.2. So total was 9 left. RC, sorry, it is equal to RC. RC is equal to how much? 4.8. Total is 12. So we can say, okay, RB is doing its work and deflection is gradually reducing, still it is not zero. Clear? Now again, with the help of some different computer software, suppose we are increasing RB again, we are giving RB equal to 6 kilonewton. So how much is left? 6 is left. So suppose the software is telling RA equal to 2.4 kilonewton, RC is equal to 3.6 kilonewton. These are all approximate values from software. We are not solving any problem. We are just trying to understand the concept of redundancy, that what is the basically the function of RB. Clear? So see, again the deflection is minimum, but still it is not zero. Finally the computer suggests that okay, if you give RB equal to suppose 7 kilonewton, then the deflection will be zero at this point. If we take out 7, how much is left? 5 kilonewton. So 5 kilonewton, suppose you are giving it as 2 and 3. Suppose at this point of time the deflection is equal to 0, then this is the function of the redundant support, that is RB. So in case of external redundancy, there may be several case study, there may be several permutation and combination of forces. So RB force we are getting with the help of some computer software after several set of values, that okay, we have to minimize the deflection equal to 0. From here, this was the deflection, we are getting it lesser, and now it is equal to 0. So this is the basic idea of external redundancy. In the next class we will see the basic idea of internal redundancy. Okay, just remember one point: external redundancy is caused by more number of support, that is, these are also called as redundant support. Clear? Okay, thank you.